Hello everyone, welcome to the new section. In this section, we are going to read about EDA on the text data, and we will be working on the women's e-commerce clothing reviews, and it has the many input parameters. We will first start with the data preparation and the data cleaning. After the data cleaning, then we will start our feature engineering, and then finally we will start our distribution plot with the plotly, and then we will be seeing a many distribution plot in the form of the univariate analysis as well as with the bivariate analysis. And then we will be also seeing the unigrams, bigrams and trigrams analysis of these words, and then we will be trying to find out the most occurring words. That's mean the what are the frequencies and how these words are occurring. And then finally we will see the parts of speech tagging. That's mean we will be seeing that what type of the words are being used in these reviews. And then we will lead to a bivariate analysis. In a bivariate analysis, we will be using a multiple inputs like X and the Y for a division name and the polarity to analyze our reviews and how these are correlated with each other. And then finally in the final piece of this sections, we will be also taking two continuous variables in the form of the distribution plot as well as in the form of histogram, and then in the form of joint plot. Alright, so this is all about in this lesson. Thanks for watching. I'll see you in the next lesson where we will start this section. Alright, now let's go ahead and get started with the exploratory data analysis on a text data. And in this lesson, we will be taking women's e-commerce clothing reviews. And this data is also available on a Kaggle. You can get it from a Kaggle, their women's e-commerce clothing reviews. And there are 23,000 customer reviews and ratings are there. It has you see there it has a input column as a clothing ID, age, title, review text, rating, recommended IND, and that's mean it is recommended or not. That's the recommended index, and then positive feedback count, and then it has a division name, department name and class name. Alright. So what we are going to do, we are going to copy it so that we can later understand our text data in a more better way. And this is the information which we have currently. I'm just going to put it here, some new lines. Alright, so there we have, and here we have, and there it is. Alright, so these are the information which we have there, and if you want to download this data, then you can download it. Let me also paste here its link as well, so that you can also download this data from this link there. Although I have already included this data into the folder, I mean in the working directory, there is women's clothing e-commerce reviews. Alright. Now let's go ahead and import the necessary packages, but before that let me insert few cells so that we can work here comfortably. Alright. And the Python packages which we will be using in this lesson, we will be using pandas of course. So import pandas as pd, import numpy as np, and then we are going to import here matplotlib.pyplot as a plt, and we are also going to import here seaborn as sns, and then finally, as you know, we are going to put here matplotlib and with the inline. So it will make sure that all the plots should be plotted in this Jupyter notebook itself. And apart from that, let's go ahead and zoom this notebook a little so that you can follow this code in your mobile as well. Alright, apart from that, we will be using here a plotly, and for a plotly, you can import the plotly from in fact, let's go ahead first import a plotly. So we are gonna do that, import plotly as py, and then I'm gonna also import cufflinks. So we'll be also using here a cufflinks as a CF, and we will be using this plotly and cufflinks in offline mode. That's mean you need to do here from plotly dot offline import iplot, and we will be also importing cufflinks. Yes, we have already done the cufflinks. Now we are going to set this Jupyter notebook in offline mode. That's mean this Jupyter notebook can use plotly and cufflinks in offline mode. So that's the py, that's mean plotly dot offline. Then I'm going to use here init notebook mode, and there I'm going to say that connected is equal to true, and then I'm also going to say here CF, that's the cufflink dot go underscore offline, and there you have got here plotly and cufflinks in offline mode. Now we are ready to get started, but before that let me also show you, if you do not have this plotly and cufflinks in your computer, then how you can install those. I'm gonna put here, you can do pip install plotly, and then you can also run here pip install cufflinks, and we are also gonna use here a text blob. So you also need to install here text blob, install text blob. So this text blob we will be using for the parts of speech tagging, as well as we will be also using it for the sentiment analysis. Then you need to run these. You can simply run it by hitting here shift and the enter, then it will install the necessary packages. All right, now we are ready to go ahead, and I'll see you in next lesson, where we will start with importing the data and analyzing it. Alright, now let's go ahead and get started with data import. So we'll be using here a pandas data frame to import the CSV file, which we had seen earlier, that was women's clothing e-commerce reviews, and we are gonna use here PD is equal, not PD equal, actually the DF, that's the data frame, is equal to PD dot read underscore CSV, that's mean the comma separated values. Let's go ahead and type here few names, and then you can press a tab in your keyboard. It will automatically complete its the file. So we have here women's clothing e-commerce reviews.csv, and then I'm gonna set here index column is 0. Now let's go ahead and see a first few lines of this data frame. There we have a first few line of this data frame. There we have clothing ID and age, title, review text, rating, recommended index, and then we have here a positive feedback count. Then we have here a division name and department name. Apart from that, we have one more, that's the class name. Alright, so these are the data which we have currently with us, and now I'm gonna show you how you can actually the few things which actually we do not need in this lesson, like a clothing ID and title. So these things actually doesn't show anything. So I'm gonna drop those. So how I can do that? So I can write there df dot drop, and then I'm gonna provide here a subset. Alright, subset, otherwise you press there shift and the tab. Actually it's a label here as well, so you can type there the labels which we are gonna drop, and the labels we are gonna drop here title, and apart from that we are also gonna drop here clothing ID. So I'm gonna put here clothing ID, and we are gonna drop it from axis 1, that's mean from a column. So I need to put here axis 1, and then I also want to replace the new data set in this current data frame, that's in place is equal to true. Now you can see your head, df head, we do not have any title and clothing ID in this new data frame. Now let's go ahead and see if there is any null values present in this data set. That we can check with df.isNull. Once you do this df.isNull, it gives you true and the false for all the rows. And if you want to get here the total number of null values present in each of these columns, then you need to do here a sum. You can do here a sum. So that's mean it will give you age do not have any null values, but review text have 45 null values. So if review text have 845 null values, that's mean there is no need to include those null values in our data visualization. So we are gonna drop these rows as well. Apart from that, there are 14 rows in division, department and the class name which has null values. So the first of all, we are gonna drop those subset. That's mean the df dot drop na. So here null values we are gonna drop here, and the subset, that's mean the column in which we are gonna look a subset, we are gonna use here review text. All right. And apart from that, we are also gonna use here a division name. Now do you see here division name, department name and class name? All of these three have null values in 14 rows. So it is very highly likely that all these values are null for a same rows. So I'm just gonna include here a division name, and then I'll check that how many values are still left null as a null. So I'm also gonna put here in place is equal to true. That's mean this data frame will be replaced with the new. Then here we have again df.isNull, and then finally I'm gonna put here a sum. That's mean I'm gonna sum all the null values. It says that there is no null values left in this data frame. That's mean we are good to go ahead. Perfect. Now let's go ahead and see these review text and try to understand that what are the values which these text have. So what I'm gonna do here, I'm gonna first convert that in a series. That's mean I'm gonna put here review underscore text. Now it has become a series, and then I'm gonna convert it into a list. Now it has become here a list, and once it becomes a list, then I'm gonna convert it into a text. That's mean all the list I'm gonna join it together so that it can be converted into a single format of text. Alright, so now you see there it is just text here. A whole data frame reviews has been combined in the single text file, kind of text file, and there you see few of there are a lot of the special characters. So special characters are not gonna bother us, but there you see there is backward slash. So these backward slash might create a problem. And there are a lot of the words which are into a contraction form. We need to expand these, like it's here. So it is this one is it is, and there we have I am. So that should be the I space M. And similarly there you see there we have a 5 backward slash, then single quote and 8, and then double quote. That's mean it's a 5 feet and 8 inches. And there are, you again see there. So that's mean we need to first convert our this contraction form into the expanded mode, and thereafter we can remove these backward slash. So those things we will see in the next lesson. So thanks for watching. I'll see you in next lesson. Alright, now let's go ahead and get started with the text cleaning. And this text cleaning, as earlier we had seen that there were a lot of words which were in a contraction form. That's mean we need to convert those contracted form in the expanded mode. So I have taken these words from a Wikipedia, and in the Wikipedia it is given that the contracted and the expanded format. That's mean if you have this word, that's mean the expanded format of this word is I am, I'm not, and then here we have aren't, that's mean are not. Then we have here a can't, that's mean cannot. And similarly we have a lot of the other contractions, and then we have there the expanded form of those contractions. Now we need to apply these contractions on this data set so that we can convert all those contracted form of the data into expanded mode. So what I'm going to do here, I'm going to first write here a lambda function. With the lambda functions I can do these things very easily, but before that I need to here define a method which will do these operations. So I'm going to do here def is equal to cont, that's mean the contraction to expansion mode, that's the exp, and there I'm going to take a text as an input, and then I'm going to check here if the type of that text, alright, so that's the x is str, that's mean we need to operate only when that text is string. Otherwise if it is a numerical numbers, then we cannot apply the contractions. And then I'm gonna say that x is equal to x dot replace. The first of all I'm gonna replace this backward slash with the nothing, and as you see that once we put here a backward slash, that's mean immediately after this backward slash, immediately after this text the meaning will be nothing there. That's mean it is not the right way to do this. I need to put here a double backward slash, then it will make sure that this double backward slash, that's mean it will take this single backward slash as a meaning of it, and then finally it will replace those with nothing. Alright, and then I'm gonna do here for key in contractions, and then I'm gonna check it here with the value is equal to contractions for that key. That's mean what I'm gonna do here, I'm gonna first iterate over these contractions, and then I'm gonna check that if those contractions occur in this text data, then we need to replace with those values. That's mean this is a value for this dictionary. So there is a key and then there is a final value which we need. Alright, now apart from this, we are gonna do that x is equal to x dot replace, and there I'm gonna use a key, and then I'm gonna replace it with the value, and then finally after this for loop I can return a value which we need here. Otherwise if the data is in integer format itself, then we can return x directly, and I need to also put here x as well. So there we have our method for a contraction to expansion mode. Now let's go ahead and check it. We can check it with the new text data. So I'm gonna put here a new text data like this. Let's say I write something like this, but you see there I need to use here double quote so that I can use the single quote inside this string. So I say that I don't know what date is today. Alright, then I'm gonna put here I am 5 feet. Let's say I'm gonna put here I am 5 feet and 8 inches. So as soon as I put here a double quote, that's when I need to put here a backward slash, so it will make sure that this double quote is included in this string. Alright, so I'm gonna run it. Let's go ahead, run it, and then we are gonna apply this contraction to expansion method. Let's go ahead and call this with the cont, and there we have it, and we are gonna pass here x, and we are also gonna print it here. Once you there is a problem. Once you print it, now you will see there we have I do not know what date is today. I am 5 feet and 8 inch. Alright, so this is we are gonna apply it on the text data which we had earlier, and there I'm gonna use here lambda method, and we are also gonna put here a magic command in a Jupyter notebook, so it will count, it will estimate the total time which will take to execute this cell. And there we have df, and then again we have their review text is equal to df dot then we have their review text dot apply, and then we have here a lambda x, then cont to it should be contraction to expansion there, Then I'm going to pass here x. So how it is working? It is passing a row by row text data in this x variable, and then this x variable is being passed to this method which we defined earlier, and then the final result is being returned, which will be stored into that particular row of review text. Let's go ahead and run it and see how much time it is going to take. It says that there is an error. It says that, yes, I think it was wrong a little, and then it took around 1.5 seconds. So we are done here, and once again we are going to see here a df dot head, and with this we are going to see here a first 5 lines. All right, so another method which we are going to do here, again the same thing we are going to do there, which we did here. All right, perfect. Let's go ahead and run it. The one thing I'll tell you here, which you will notice that there is still some backward slash inside that, but otherwise you will see there the most of the things has got corrected. Like there were a lot of its, now it is converted into the itage. All right, but still there you see a few backward slash is still there. It happens because this is the raw text and we have not used here a print, and that is why it is there a backward slash. Although we can use here a print, but the problem with the print is once we use that print, what we will get there, we will get the error. So error was the input output operation is not the executed. I mean, it's not allowing the operation. You can use it here if you want, but you will see that. So input output data rate is exceeded. So for that, what we can do, we can take just few characters. So let's go ahead and take the first 1000 characters, and then you see there we have got it here a 5 feet and 8 inches. All right, so this is all about in this lesson. Thanks for watching, and I'll see you in next lesson where we will start average word length and a little bit more data cleaning part. I'll see you in next lesson. Alright, so in this lesson, I'm going to show you how you can do a feature engineering in the text data. That's mean we will be calculating few features in the text data before any visualization. That's been the thing which we have been doing. This is the part of the text data preparation and the cleaning, and it is really important whether you are just gonna do a visualization or you are gonna write some machine learning code. So in both way, you actually need these things. Now let's go ahead and do this feature engineering. For that, what I'm going to do here, I'm going to first visualize this df. I'm going to just see a first few lines again in a df. We have here age, review text, rating, all those things. So we are going to first calculate the total number of words present in each of these review text. And apart from that, I'm also going to calculate how many characters are there, and then what is the average word length for each of these reviews. Average word length means how many character word have on average. For example, this silky have just 5 characters, and here it is a 3, and then there is a 4 and 3. Alright, so let's go ahead and calculate those features, and we will be also calculating their sentiment polarity as well. So we'll be using here a text blob to calculate the sentiment of the text, and but before that I need to import the text blob here. So you can write there from text blob import text blob. All right, so there we have got the text blob, and then we have here a df head, and now let's go ahead get started with the first polarity. So there we have a polarity. That's mean what is the sentiment polarity for a particular text, that we can do with df polarity is equal to df, and then here we have a review text. All right, so we are gonna again apply here a lambda function. So we'll be using lambda function most of the time, very frequently. So we have here a lambda x, and then I'm gonna apply here a text blob sentiment. All right, so there we have their text blob. In this text blob, I'm going to pass here x, and then finally I'm going to call here sentiment, then dot polarity. So it will return there a polarity in this df polarity. And apart from that, I'm also gonna do some review length. Alright, so there we have review underscore length, and again I'm gonna apply here a review text. So let's go ahead, copy it, otherwise just press here a tab in your keyboard. You will see that it is completed, auto completion is there. And then we have there again apply lambda x is there, and then finally we are calculating here a review length. That's mean we are calculating the total number of characters, how many characters are there. So we are just gonna put here simply len of x, and then finally we are gonna calculate the total number of words present in each of these reviews. That's we are gonna put here word underscore count actually. All right, so there we have a df, and then again we have here a review text dot apply, and then we have again lambda x. Now you see we have this complete text data for each of these rows. To calculate the number of words, we need to split these rows. So those rows can be splitted with like this, a split, and then finally we are gonna calculate the length of this split. That's mean the length of words. That's mean the total word count is calculated, and it is inside the word count. Now finally I'm gonna calculate the average word length in each of these reviews, and for that we need to write here a method, and that method we can write with def get underscore avg underscore word underscore len. That's mean the average word len. Inside that I'm gonna pass here row text data, that is x, and then finally words is equal to x dot split, and then I'm gonna do here word underscore len is equal to 0, and then finally for word in words, that's mean I'm gonna iterate over the words. Once it is done, then I'm gonna calculate here word len is equal to word len, and then finally I'm gonna put here addition of word. Alright, so for each of these words a total word len will be calculated. You do remember you could have done directly len of this x, but in that space is also included, but we do not need to include those space because the words are not made of spaces. Alright, so that is why we need to calculate these length of words word by word. Once it is done, then we are gonna return here a total word length. So there we have word length. We do not need actually equal to here. So it's a simply word length and then divided by a length of words. Alright, so there we have words. That's mean how many words are there. And this says that the total number of characters present in that words. Alright, perfect. So let's go ahead and run it and then finally apply it inside the new column. So new column which I'm gonna create here, that I'm gonna put here avg underscore word and then underscore length. That's mean average word length. Then I'm gonna put here df review text, then again apply, and then again we have here lambda x, and then finally we are gonna call here get average word length, and inside that we are gonna pass here x. It will take a little time. Now it is completed all those things. Let's go ahead and see a first few lines with df.head, and in this you have got here there is a polarity, and we have also got here word counts and average word length. So it says that how many on average a word is made of with characters. So it says that in the first review, so there is 5.75 characters in each of those words on average. Alright, perfect. And now I'm gonna show you a few random samples so that you can also calculate these polarity. like this, without the random sample. In fact, you can verify it. Like here you see there is absolutely wonderful, silky and the sexy and the comfortable thing, something is there, and it says that the polarity is 0.63. That's mean yes, it is a very high positive review there. And there is just 0.07 in a polarity. That's mean it is kind of a neutral review. That's mean there is no positive and there is no negative. And this review also, if you read it, you will understand that like I had such high hopes for this dress, and really that's mean with this only we have got the information that someone hoped something, this is gonna be great, but this is just so. That's mean there is just a neutral sentiment are there. And with this 0.55 it says that I love. Alright, so with this, that's when there is a positive sentiment. So if it's a +1, that's mean it's a very high positive sentiment, and if it is a -1, that's mean it's a highly negative, and if it is somewhere around the 0, that's mean it's the mostly a neutral review is there. Alright, so this is all about in this lesson. Thanks for watching. In the next lesson we will start plotting the data. Bye bye. See you in next lesson. Alright, now let's go ahead and get started with distribution of a sentiment polarity. So we already have our DF, in which we have calculated few custom features as well, like a polarity, average word length, and word count. So we are going to first apply our distribution analysis on the polarity, and then we will continue for other columns as well. And there we are going to use here a cufflinks and plotly together. A cufflink is a package, a Python package which bind pandas data frame and plotly together, and it is really very easy to use there. By default we can just simply write here df.iplot, so it will automatically plot all these columns which are numerical column. I'm just gonna show you how you can actually use this df.iplot without selecting any particular column there. And we have here plotted it, and by default it seems that it is kind of a bar plot, and this bar plot is highly mixed together. So what I'm gonna do here, I'm gonna select particularly only polarity here, so that we can only plot here polarity. With this we have seen the most of the polarity is here varying somewhere in between -1 to the +1. But in general it is somewhere, it seems the 0.25 in the positive. That means it says that the most of the reviews are positive there. Alright, perfect. Now what I'm gonna do here, I'm gonna change this in a histogram so that you can look it very clearly. So you need to press here Shift and the Tab, then you will see there by default it is a scatter plot. So the kind which I'm gonna use here, I'm gonna change it here a hist. That's mean now it will become here a histogram. So with this histogram, you see there it has something like this, but we are gonna do here a few more things. Like we are gonna change here the color of this. So the colors, I'm gonna use here a red color. Let's go ahead and use this. So there we have got the red color. But after the red color, you see there is the red color is not the properly visible. So I'm gonna also put here a bin. So that's the bins. That's mean it is gonna say that how many bins are gonna be here. So I'm gonna put it here a 50. So with these 50 bins, you will be able to visualize this the pretty much the clearly. It's more of the clear and the pretty much clear. Alright, so it says that the most of the reviews are concentrated somewhere around 0.17 to 0.22, and there you see a lot of the reviews are somewhere in between 0. You see there this one, it starts from the 0.12 and then there is a 0.32. That's mean if you take these just 4 bars, with this you will get that the most of the customers are satisfied. But still there are a few customers who are not satisfied, and those unsatisfied customers list are really low as comparison to the satisfied customers. Alright, perfect. So this is all about In fact, before ending this lesson, let me also show you few more things like how you can add their title. So I'm going to put here X title. So there you can see X title, that's in the X label. So in the X label, I'm going to show that this is polarity. In fact, let's go ahead and put this P in capital. And then finally, we have Y title. The Y title is equivalent to Y label. So we have their Y title, and in the Y title, we have here a count. And apart from that, we have a title. So the title which we will be using for this plot, that's the, I'm gonna say that sentiment polarity. So this should be the sentiment polarity distribution. Alright, so let's go ahead and run it. Now you see there it has a sentiment polarity distribution, there is a count, and this says that the polarity. Alright, so this is all about in this lesson. Thanks for watching. I'll see you in next lesson. Alright, now let's go ahead and get started with distribution of reviews rating and reviewers age. So we have here a data frame DF, and the column rating represents the rating of that particular product by a particular reviewers. So there I'm gonna put their DF rating. So it will return here a series, and in this series I'm gonna use here iPlot, that's mean the Plotly iPlot. And then in this I'm gonna represent kind is equal to hist, that's mean this is a histogram plot. And once again I'm gonna put here X title, and that X title I'm gonna put their rating, and similarly I'm gonna put their Y title. Y title is count, that's mean how many ratings are there for that particular rating. And then I'm gonna put there a title for this plot. So we have here a title is equal to review rating, alright, distribution. Perfect. Let's go ahead and plot it. So what do you see the difference here? Our default color is here a yellow color, and apart from that I have also not I have not given the color, so that's okay. And there the most of the ratings there a 5-star rating, and then we have a 4-star, 3 stars, and there are a few ratings are 1 star. That means this says that these are the mostly unsatisfied customers, and these are the highly satisfied, and these you can say the satisfied customers. And the mostly 3 comes okay, this is the neutral review. Alright, so this is how you can do a review rating distribution. Now let's go ahead and see there a review rating, the reviewers age distribution. Then I'll show you how can you do that. So there is just DF, and then again there is age, and then we are gonna say that iPlot, and then again with the kind I'm gonna say that hist, that's mean the histogram, and number of bins I'm gonna use here 40, and then I'm gonna use here again X title. The X title for this I'm gonna use here age, and then finally we have here Y title, and in the Y title we have their count. Alright, and then finally we are gonna see here a final title. So this final title says that reviewers. Alright, so there we are gonna say that reviewers, so there we have reviewers age distribution. So I'm just going to write there the dist. Alright, let's go ahead and plot it. Once again you will see there the most of the reviewers who had left the review, so their age is somewhere in between 35 to 39 years. And apart from that, the nearby of that you will see that it's 30 and their age 44. That's mean the most of the people are inside these 15 year of range, that's mean 30 to 44 years. So these have the mostly the left the reviews. And now let's go ahead and see if you want to change the color of this plot. How do you do that? Similarly, as we did earlier, you can change the color from here, like colors is equal to the red, You can also put here yellow color as well if you want. You can also put here aqua color, and then if you want you can also put there the magenta color as well. Apart from that, you can also put there a green color, and then a default color is orange, which is available in the Plotly like this. And similarly, you can also change this line color as well. If you want to change the line color, you can simply put there line color equal to, let's say you want to put it red, then you will see that the line has been changed into a red color. And if you want it into the yellow, then it will be changed to yellow color. And if you want it into a black, you will see here it is in black color. I don't know if gray is also there. Yes, gray is also there, and by default the color is gray color. Alright, perfect. So this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you how you can see a distribution of review text length and word length and other things. Bye bye. See you in next lesson. Alright. So now let's go ahead and get started with distribution of review text length and word length. We will be also taking lesson on average word length as well. So once again with the same thing, we are gonna start here with the review. As you know, we had the review length. Again we are gonna do here iPlot. So once you do this, you will automatically get this in the form of the scatter plot. But I'm gonna change here a kind, and the kind I'm gonna put here a histogram kind, and it says that the most of the reviews are somewhere around the 500, and the other reviews are constantly in between 100, 200, 300, but here most of the review length are 500 characters, are somewhere nearby, you can say. Alright, now what I'm gonna do here, I'm also gonna put here a bin, total bin size, otherwise let it be whatever it is. Then I'm gonna put here X title. I'm gonna say that review length, and then we have Y title, and once again we are having here count in Y, then we have their title. So in the title I'm gonna say that review text length. Alright, perfect. So there we have, and in fact I can say the review text length distribution. Alright, so this is how we are this is how you can do review length distribution. And similarly copy it and paste it here. Now you can change it to a review count, sorry, a word count. So in the word count we had there word underscore count, and then you can change there like this word count, and this is the count, and then the word count. Actually, let's go ahead and write it once again. So we have here a word count distribution. Alright, let's go ahead and run it. So it says that most of the reviews are having around the 100 words per review. So you see there the most of the reviews are having the 100, and then again it is decreasing suddenly there once it is reaching somewhere around 110 and 111. And similarly you see there the most of other reviews, the constantly they are around they start somewhere around the 20, and then it varies around the 20, 30, 40 kind of the things there. So they are the mostly the same. Alright, so similarly let's go ahead, copy it and paste it here again, and then I'm gonna put here average word length. And this in this average word length, so I'm gonna put there AVG word length. Alright, and then here I have a average word review text AVG word length distribution. Alright, so their review text average word length distribution. So it says that the most of the words on average their length is 4. That's mean the word is made up of 4 characters, and apart from that mostly it seems that around 90 or 85% of the words are made up of somewhere around 3 characters. You can say yes, not a 3, but it's around the 3.8 characters to around 4.2 characters. So this is the on average. Okay, so there is no 3.8 characters in a word. So it says that the on average, the most of the words length for particular reviews are somewhere around 4. You can say it is varying a little less or a little larger, but still there are a few words which have actually a high length in the characters. So those could be wrong spelling, otherwise those could be repeated characters, otherwise those could be also a genuine word as well. All right, so apart from that, once again let's go ahead and see this one. Okay, word count distribution. So I'm gonna just copy it and then I'm gonna paste it here, and once you paste it here, hit the enter here so that we can get some space there, and then you need to come here, press there shift and the double tab. Once you press here shift and the double tab, you will see there a detailed documentation, and in that detailed documentation you see there is a kind parameter. This kind parameter says that we have here a bar plot, box plot, spread plot, ratio, heat map, surface, histogram, bubble, scatter. So all these plots which we can use in this Plotly. All right, perfect. All right, so this is all about in this lesson. Thanks for watching. In the next lesson I'll show you how you can work with the distribution of department name and class name and then the division name. So those are kind of the categorical values. All right, see you in next lesson. All right, now let's go ahead and get started with the distribution of division, department and class. So here we are going to use new concept of a pandas data frame. So there we have a group by which we have used earlier. So we are going to use here df dot group by. All right, and then I'm gonna group it with the department name. Okay, so once you put there, it's actually I think the department under this space and name. So there you will get a group by object. So what it do, it group all those. Let me show you first head of this data frame with just one character with one row. So with this one row you get there is a department name. So with this department name there is many departments. So those department length you can get with df dot department name dot value underscore counts. So it says that so these are the departments which are available, like tops, dresses, bottoms, intimate jackets, count, etc. So this is the same thing we can do with the count. All right, so once you do this, what it does, it counts all those department name and then it finally consider all those together, and then finally it counts how many people are with the age and all those things. All right, so there is age. So it says that okay, the count of those people who falls in this category, so that is this number, and this number you can verify with here a bottoms says that 3662, and this is same for all others as well. All right, and similarly we have all those things other, I mean the count for other department names as well. All right, so in this what I'm gonna do here, so this is how it is working. So either we can take this one or this one. So by default I'm gonna take this one. So I'm just gonna copy it and then finally I'm gonna paste it here, and then we can plot it with the iplot. And this iplot is in the form of the scatter plot, and which is being plotted as a line plot as well, since this is kind of the continuous line, so those are being connected together. All right, so what is happening here, I'm gonna also provide here kind is equal to bar plot. All right, then it will be plotted in the form of this bar plot, and it says that there are around the 10,000 tops and then dresses, bottoms. That's in the reviews which have came mostly on the top, dresses, bottoms, then there is intimate, jackets, and then finally trends. So this is how it is working. Now apart from this, once again, if you want to put here the titles and X title and the Y title, you can put here again. So there we have Y title is equal to count, again since this is univariate plot, and then we have their X title. In the X title we are saying that this is department. Alright, so we are gonna plot it. There's actually the X title should not be like that. So this should be like this, and then finally I'm gonna also put here a title. In that title I'm gonna say that department. Alright, so department name, actually bar chart of department names. Alright, I can do something, let me put here a backward slash. No, backward slash is not gonna work, so I need to put here a double quote and then double quote here. So it says that bar chart of department names. Otherwise you can also say that here a department's name. Actually I think that makes sense. All right, so the same thing which we will say, the same thing we are gonna do with the division as well. So I'm just gonna copy it and then I'm gonna paste it here, but before that I need to get there a division name. Not before that, in fact we are gonna do here as well. So that's the division name, and then finally we can say that okay, so this is division, and I think we have missed this line as well, so that I'm gonna paste it here, bar chart of division's name. All right, let's go ahead and plot it. So it says that there is an error, division name, there is no division name. What is the name of it? It's division name. Yes, it's there. I think the spelling is wrong. Oh sorry, that's the division name, I'm sorry. So now we have a bar chart of division's name, and there we have a count and the division. So it says that generally we have got, in that data file, so the most of the reviews are from general division, then the general petite, and then the intimates division. So there is a little difference because every division have a different department as well. So that is why it is changing a little in the intimates there. Alright, now let's go ahead and do the same thing for the, I think we are done with the division and the department. Now we are left with the class. So there I'm gonna do it with class name, and again I'm gonna put it here class and bar chart of classes name. So there we have many classes like dresses, knits, blouse, sweaters, pants, jeans, and the most of the reviews come in dresses class. All right, and then there is knits, and then there is blouse, sweaters, all those things. All right, so this is all about in this lesson. Thanks for watching. In the next lesson we will start with the distribution of unigram data points. I'll see you in next lesson. All right, so now let's go ahead and get started with the distribution of unigram, bigram, and trigram. So the trigram means there is a collection of 3 words together. Unigram means there is just 1 word, and bigram means there is 2 words together. To understand this with an example, let me first write an X there. So this says that this is a text example, let's say. All right, so in this what you will get, in a unigram you will get multiple words like this, and then there is, then a, and then finally test, and then you will get the example. But in a bigram you will get 2 words together like this is, then is a, and then then you will get there a test, and then you will get their test example. All right, so this is how you will get these together. And then with the trigram, similarly with the trigram, the words are like this is a, and then is a test, and then you will get a test example. All right, so this is how you will get the unigram, bigram, and trigram. So with this, now we are going to see that what are the frequencies of these words in the form of unigram, bigram, and trigram. In a unigram, we will be analyzing words by word, but in the bigram, we will be analyzing a combination of words. So if you want to find out those two words which comes together, then you should use a bigram. But if you are looking for the trigram, that's when the three words comes together, then you should use a trigram, and similarly for other gram as well, like ngram. And the new library, in fact new Python package which we will be using here, that's the sklearn. Sklearn automatically comes with the Anaconda. So if you have installed the Anaconda, you will directly get the sklearn. So there you have from sklearn dot feature underscore extraction dot text. All right, then you are gonna do there import count vectorizer. I'll show you how this count vectorizer work. A count vectorizer counts these words together. That's when the count vectorizer actually count the words, unique words you can say. Alright, so now let's go ahead and work with count vectorizer. So I'm gonna first define a new x here, and do remember count vectorizer takes a string in the form of list. So I'm gonna put here this is let's say, yeah, so sorry, this is the list. Then I'm gonna again say that this is the list, and then again I'm gonna say that this. All right, so that's the x which we have currently. Then finally I'm gonna say that wec is equal to count vectorizer, and inside this I'm gonna fit it with this x value. Then we have got here our vec, that's the vector, and it says that it has used the analyzer word, and then finally it says that maximum feature is none, and other things are by default it is set like stop words, etc., although that we will be using. Since we are doing with the unigram, that is why this n-gram range is set here 1. That's mean it's a unigram. Then I'm gonna store here a bag of words, that's the BOW is equal to a vec dot transform. Alright, so there I'm gonna do that transform, and inside that I'm gonna again pass their x value. Alright, and then let's go ahead and check this bag of words. Here we have got a sparse matrix, and it says that it has 4 unique words, and definitely we have here 4 unique words. This is the list, these are the 4 unique words. Then we have here a sum of words, so let's go ahead and get those sum. In fact some words actually. So sum words is equal to BOW dot sum, and then I'm gonna say that with x is equal to 0, and then you can get this sum words. So this is the sum words, and now our task is to get the vocabulary items. So those you can get with the vocabulary. All right, so there we have vocabulary, and then finally we are gonna get it with the items. All right, so again it is saying that it do not have any, I think yes, some words is not that should be the vector. So it says that this is a 3 time occurs, and sorry, this is not a 3 time occur, but actually this what it is saying that this inside this sum word is at the 3rd place, then is at 1st place. That's mean if you print it here, so in this the index of this is this one. All right, and then is is this one, and the is here, and for a list we have here. And you can verify this with like this. So there we have. So again, this is at the third location, that's mean here it is because this has occurred here 3 times. To make it a little more clear, you can make it here. Again, you see there we have this for 4 times, and that 4 occurs here, and the index of this is 3, that's mean it has here. Alright, so now what we are going to do here, I'm going to create here word frequency dictionary here, and we will be also taking this some words together as well. So how I'm going to do this, so I'm going to use here a list in fact, and then I'm going to write some code in this list. How I'm going to do that? So the first of all, I'm going to apply there a for loop for word, that's mean the first one is word, and then here we have index, that's the IDX in this vocabulary items. And once you have this, that's mean you have got this word and index together. Then I'm gonna put this word and index in this some words, and from there I'll get these words and its frequency. So that I can get it here like some words, and inside that I'm gonna choose their 0, and then I'm gonna choose their IDX. Alright, so that's been the index, and apart from that I'm also gonna use their word, that's mean this word. So with this, how it will work, so it will group this word and its index, that's mean here this index together, so it will become word and its frequency together. I'm gonna close this list there, and somehow it says that this is the invalid. Yes, so I think that should be placed inside a tuple. Yes, so it says that this has occurred 4 times, each is 1 time, the is 1 time, and list is 2 times. So that I'm gonna take it into words underscore freq, that's mean that's the word frequency, and then I'm gonna sort it by its descending order. So that's mean this will come first, and then list, and then each, and then the. Alright, so there we have words underscore freq is equal to sorted. So there we have a sorted, that's mean it will sort it words frequencies, and I'm gonna sort it by key and the value that key has. So that I'm gonna do it with the lambda. So there I have a lambda x, and then finally I'm gonna take their first value, that's mean it's actually the second in the x. So this x is not this x, but this is a word frequency. Alright, perfect, and then it is passing this tuple one by one. So this one is says that this is the frequency. Alright, so x1 is a frequency in that tuple, and then finally I'm gonna say that reverse is equal to true, that means sort it into a descending orders. Alright, so I'm gonna again take here words frequencies. Now we have got here this list is and the in a sorted format, and once you get it, then we can let's say if you want to take just first 2 values, then how would you get that? You can just put it here like 2, then you will get just first 2 values. Alright, so this is the code. Now let's go ahead and put it into a function. So I'm gonna just copy it here, and then I'm gonna define it like def get underscore top underscore n, and then words. Alright, so there I'm gonna put here x, and then I'm also gonna pass the values which it wants written, how many values, so that is gonna be n. Alright, so let's go ahead and paste it here. Once you paste it here, I need to press here a tab so that the alignment can be done here, and then we have here a vector. All those things are good to go, and then here we only need to change their n. Alright, so there we have got def top in words. Alright, now let's go ahead and check it. Get top in words, and there I'm gonna pass here x, and then again a 2. So it returns nothing because I have not written here a return, now you will get the same result as we have got the earlier. And similarly, if you want here 3 values, then you can write there a 3, it will return a 3 values. Alright, so now we are gonna use it here. We are gonna use it for the review text, so that we can get it like this. Let's say we have words is equal to get top n words, and in this I'm gonna pass there df review text. All right, so the review text will be passed here and unigram will be calculated here, and then I'm gonna return just top 20 words. Once you do this, it will take a little time, and then finally it will return these words together. There we have here words. All right, so these are the top 20 words, and in the next lesson we will plot these words, and we will also do it for unigram, bigram and trigram. So I'll see you in next lesson. Alright, so now let's go ahead and continue this lecture. And since we have got here our words and its frequencies mostly, and this is we have got for a review text for a unigram. Now I'm gonna create here a data frame so that we can plot it later. Otherwise, now this is the word, so I can do it with, let's say, the df1 is equal to pd dot data frame, and in that data frame I'm gonna pass this words, and if you see there df1 you have got it here, and the columns here which I'm gonna pass there, so I'm gonna say that unigram, and then I'm gonna say that frequency. All right, so okay, this is a little error there. So we have got here a unigram and its corresponding frequency. So what I'm gonna do here, again I'm gonna plot it. All right, so how I'm gonna plot it, I'm gonna just do here df1 then dot iplot. All right, once I do this, you will see there you have got unigram and it's a frequency. This is the unigram. Actually it will not work like this. So here what I'm gonna use there, I'm gonna use there a bar plot. So once you use here a kind is equal to the bar plot, then you will get here unigram and it's a frequency together. Although this is also not gonna work there, so we need few more things to plot it. So before plotting it in a bar plot, we need to set its index. So how we can do this? We can say like df1 is equal to df1 dot set underscore index. Alright, so it will set the index, and that index is unigram. So that unigram will be used as an index, and then finally we are going to plot it as a bar plot. So with this what you get there, it says that the is having maximum frequency, then it and is this, all those things. And we are also gonna set here a x-axis as well. So we have there x title is equal to, in the x title I'm gonna say that it has a text data, okay, or unigram. Actually this is not text data, that is the unigram. And then we have y title. Y title is count for those particular unigrams, and then finally I have here a title. So title says that top 20 words, okay, in fact uniwords or unigram words you can say. Alright, so let's go ahead and plot it. Now you will get here a top 20 unigram words. Alright, so this is with the including our this is included these stop words. So we have not removed those stop words. That's okay, not a problem at all. Now let's go ahead and check it for a bigram. So for checking it a bigram, what we need to do, we need to copy this one, and in fact I'm gonna put here and bigram. All right, and similarly I'm gonna put here first it is because of unigram. Alright, so that it should be clear to you later. Alright, so this is the words which we are gonna again get it. In fact, I have not pasted that part here, so I need to first get this one. Alright, in fact I need to get this one, and let's go ahead and get all these together with the just pressing C there, and then I'm gonna paste it here with the V. Alright, so this is for a bigram. So for a bigram I need to put here inside this fit. If you press there shift and double tab, not a fit but inside this count vectorizer, you will get there n-gram range. So we are gonna copy it here from here, and then you are gonna paste it here. Then let's go ahead and set it to, that's when now it is become, now it has become here bigram. Alright, in fact we do not need this. Let's go ahead and copy it, paste it here, in fact, because this was just for a testing purpose. So we have got here bigram. Alright, there is no changes here, and there you have got the bigram, this 2 times, then this is 1 time, and each the for only 1 times. And with these words we have got top 20 bigrams. It might take a little time to complete, and then if you print these words you will get these bigrams. And then similarly, instead of writing here unigram, we have got here bigram. Let's go ahead, copy it and then paste it here, and then I'm gonna also paste it here, and then I'm gonna paste it here. So with this you have got here top 20 bigram words. So these are the top 20 bigram words in the review text. And similarly, let's go ahead and do it for a trigram. So you need to select this row, and then you need to select here this last row. In fact, go ahead, first select this one, and then you need to press there shift. So keep pressing the shift, and then select all these cells which you want to copy, and then press a C in your keyboard. It will copy all these cells, and then come here, select this cell, and then press here a V key. Alright, so once you press there a V key, you will get this is here pasted here. Now you see there is 2 bigram. Alright, so this bigram I'm gonna change it to trigram, and there we also need to put there 3. Alright, so now it becomes a trigram, and this was just for a testing purpose. And there we have got trigram words. Let's go ahead and run it, and at the same time as it is running, change it to a trigram, change it also a trigram. There we have a trigram, and then okay, so it's completed. Now we have got this trigram, and there we have got a trigram. Let's go ahead and run it. So there we have got a trigram. This true to size the fabric is, and it is, this dress is, it is, but it is not. So these are the words which have been used very frequently, and these are in the form of 3 words together, which is a trigram. Alright, so this is all about in this lesson. In the next lesson I'll show you how you can remove these stop words. Stop words are those words which occur very frequently, like this, to, the, a, his, is, all those things are stop words. So I'll see you in next lesson. Alright, now let's go ahead and see distribution of unigram, bigram and trigram without a stop words. Earlier you see we have seen that these unigram, bigram and trigram distribution, word distribution, but the most of the words were coming from stop words. Stop words are those words which have a very high frequency in English literature, like we have is, the, did, not, to, those, from, that, mean, you, are, all those are stop words. So we are gonna remove those stop words. But before that, let's go ahead and copy this trigram from there. and what you need to do, select this cell and then hold your shift key, and by holding shift key you need to press this one. Okay, so you will see there these cell has been highlighted. Now you need to press a C key in your keyboard, and once you press the C key it will copy all those together, and then I'm gonna paste it here with V, and there we have got it. Since we are gonna work with unigram there, so we are gonna remove this. You can remove this by selecting it and press X key in your keyboard. Then you will see that is deleted. Since we are working with unigram, we need to change it to 1. That's mean this is unigram. Alright, apart from that, you see there we have, I'm gonna just remove it, let it be in fact, and there we have it for unigram, and again copy it and paste it here, copy it and paste it here, and then paste it here. Alright, let's go ahead and run it, then I'll show you how we can remove a stop words. So this is the same which we had plotted earlier. So this is the plot of unigrams, and most of these unigrams are stop words except here dress perhaps, and others are stop words. So let's go ahead and remove those stop words. To remove those stop words, I need to pass here a parameter stop words. So by default, I'm gonna select here an English stop words. Otherwise, you can also pass some list which you want to add as a stop words. So once I pass that English stop words, then automatically in English literature those stop words will be removed there, and then it will calculate here a new unigrams, and now you see you do not have any stop words here like we had seen earlier, the, each, that, all those. So these are the real unigram stop words. These are real unigram words which have occurred mostly in the review, and there is a plot for this. So the mostly dress, love, size, fit, like, wear, great, just, and fabric. So all these unigram words have occurred greatly. Mostly you can say. Alright, so now let's go ahead and copy it from here and hold your shift key, press here. Now you will see there you have highlighted all these cell, then press a C in your keyboard and then select this cell, press here a V in your keyboard, then it is pasted there, and then I'm gonna say that this is a bigram. Let's go ahead and copy it, run it, and then we also need to change those bigram here so that it becomes there a bigram. And apart from that, I also need to change here this unigram to bigram so that in the plot I can also show the titles and titles as a bigram. Alright, let's go ahead and run it. Now you will get here a bigram without any stop words like a true size, love, dress, usually wear. So if we remove the stop words, so these words have come together the most of the times, like you can say with the stop words it might have been true in size, I love this dress, all those things it could be, but the mostly this is how you can remove a stop words and then you can plot a purely words which matters most. Alright, so we have already copied it for a unigram. Let's go ahead and paste it again here by pressing V key in your keyboard. We will get here, and then finally we are going to change it for a trigram. Alright, copy it and run this one, and here we need to change it 3. So there we have a 3. Let's go ahead and run it. I think we have got here an error there, empty vocabulary. Perhaps the documents only contain stop words. Let me see there. Yes, so there could be somewhere where documents could be only a stop word. So what I'm gonna do here, I'm gonna just remove this, because there could be the most of the words which had just the words were not enough. That's mean if you remember, we had in the previous lesson our X. Let me show you those X here somewhere. Yes, so I'm going to show you here that yes, we had. So in this yes, we do not have any words which have continuously 3 words together. That is why it was the error there. Although let's go ahead and move ahead. There I'm going to paste it unigram to trigram, and then again here is a trigram, and then again we have there a trigram. Alright, let's go ahead and run it. So with this what we get, fit true size, there is a little difference. It's a fits and this is a fit. Runs true size, love, usually wear size. So all these are reviews which have at least these 3 words continuously, and in between there might have been some stop words. Those stop words has been removed. Alright, so this is how you can visualize your words in the form of unigram, bigram and trigram with the stop words and without stop words, and you will understand how the words are distributed in your text data. So this is all about in this lesson. Thanks for watching. In the next lesson, I'll show you how you can work with the part of speech and its distribution in the text data. See you in next lesson. Alright, now let's go ahead and get started with distribution of top 20 parts of speech or POS tags. We will be using here a text blob and NLTK library, or you can say a Python package. You need to first install NLTK. If you do not have, you can install it with a pip install NLTK. So this is the natural language processing toolkit. So there we have NLTK, run it, and if you do not have NLTK, it will install, and if you already have NLTK, it will say that requirement is already satisfied, and after that you need to import here NLTK, and once you imported the NLTK, now you need to also download few necessary packages here in the NLTK. So there you need to write there NLTK, and then you have there a download. There I'm gonna download their punctuation so that you can get it with the puncti. Alright, so that's the puncti, and then you have NLTK dot download, and there I'm gonna also download the average perceptron. Okay, so I'm gonna write there averaged underscore perceptron underscore tagger. Alright, so let's go ahead and run it. It will take a little time to complete its download, and if you have already downloaded it, it will say that these packages have been already downloaded in your computer. Alright, so once you have done it, now we do not need to use NLTK because text blob uses this NLTK automatically in the background. So we are gonna just directly use here NLTK for the parts of speech tagging. So I'm going to create here a blob. Blob is equal to text blob, which we have already imported from a text blob. There I'm going to convert a data frame in the form of string. So strdf, and then we have here a review text. Alright, and once you do this, you will get here a blob. This is a blob. And if you want to see how it is working, you can just simply copy it. Once you copy it, and I'm going to paste it here just above of it, then you will get all these elements, I mean all the text in the review in the form of there a series. That's the text. Actually it is converted into actually a string format. If there is somewhere numerical data, that will be also converted into a data type, that's the object there in the form of string actually. So we have here now a blob, and once you got their blob, then we need to actually calculate the tags by just calling their tags. So these are the tags. Alright, so once you have these tags, so once you have got all these tags, you might not understand what are these tags. Now to get all these tags, you need to get what are those tags. So I'm going to write there the NLTK dot help, and then I have there UPENN underscore tag set. So I'm going to get all those tag set. Let me see, it is giving some error. It says that it do not have the tag set. So what I'm gonna do that, I'm gonna first download those tag set as well. So I'm gonna download that tag set here, and let's go ahead and run it. So it says that this is the tag set. I'm gonna print it here. Once you print it, you will get all those tag set there. So CC is conjunction. There we have a cardinal numbers, determiners, and all these tag sets presents into a NLTK. Like 0 is a cardinal number. Then we have there RB. Let's see what is the RB. RB is adverb occasionally, and it's used there. All right. Okay. So we have there, this is the tags which we are gonna use. Now let's go ahead and write a for loop so that we can get all those tags together. So I'm gonna write there the part of speech tags, that's mean data frame POS df. Then I'm gonna write there pd dot data frame. There I have a blob which we have already created there. Then I'm going to use their tags. Now these tags in the form of tuple list will be passed into these tags, and there we have here word and then related tags there. So I also need to pass their columns. Columns is equal to words, and then I have their tags. That's the POS part of speech tags. And if you want to see, sorry, I should have done it outside of this. Then if you want to see it, you can get it here in the form of data frame. So we have here words and their related part of speech. Now what we need to do, we need to do a value count in this POS. So how we can do that? I'm gonna do again POS df is equal to POS df, and then for this part of speech dot value underscore counts. So there we have POS df. Let's go ahead and get this POS df and see there. So this is how we have got this POS df. Now what we need to do, we need to plot this POS df in the bar plot, in the form of bar plot. So that we can do with the POS df dot iplot. And then I'm gonna set here kind is equal to bar plot. Once you do this, you will get here, we have here NN, that's I think the noun. NN is noun there. It's a noun, common, singular or mass noun. And the similarly other parts of tag there. So we have a DT, J, CD, and I think this is the interjunction. And then there we have verb, and this is the conjunction. So all these are the part of speech. So in the reviews, most of the reviews are the form of noun. Then we have their determinant, and then there is a cardinal numbers as well. All right. So this is all about in this lesson. Thanks for watching. In the next lesson, we will start with bivariate analysis. That means we will be taking two variables together, and then we will try to find out the correlation between those two variables. So this is all about in this lesson. Thanks for watching. I'll see you in next lesson. Alright, now let's go ahead and do here a bivariate analysis. That means we will be also taking a multiple variables together. So the first of all, we are going to use here a pair plot. If you remember, we have already imported Seaborn as SNS. So the first of all, I'm going to use here a pair plot. But before that, let me also plot, not a plot, but let's go ahead and see a first few line of a data frame. So there I'm going to see just two lines. That's mean the two rows of this data frame. And there we see we have a recommended rating, a recommended index, positive feedback counts, and all other things in the numerical form. So I'm going to create a pair plot between all these numerical columns. So you can use SNS dot pair plot. Once you use their pair plot, then press shift and the double tap, you will get there the information. Which information you need to pass in this pair plot. You need to pass here data, and then if you want to pass the any hue, that's when if you want to distribute your data, break down your data on any particular column, you can do all those things. Alright, so I'm gonna pass here the data frame which we have currently, that's the DF, and once you pass this, all the numerical columns will be plotted here in the form of pair plot. So let's go ahead, just wait for some time. It might take a little time because there is a lot of the data. I think yes, it is a plotting. Just wait for a few seconds. Da 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 da. Yes. So the pair plot is plotted here. So this is kind of a very wiggly jiggly pair plot because there is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 columns. That's mean 8 by 8 matrix is plotted here. And can we see any relation here? We have there is a polarity. So this polarity says that something is a positive relation if we, I mean it's kind of there is a positive correlation. That's when there is a positive slope there. So it says that if average word length, I mean word length is more, then there is very high probability that it's a positive sentiment. And similarly, if word count, you see there, let me see, is there any positive? I think something is here also. Yes. So it says that the positive feedback count, of course, if positive feedback count is more, then there is more positive polarity. So this is kind of there you see, we have a positive slope there. All right, perfect. And very interesting relation here between the review length and word count. So as word count is increasing, review length is also increasing, and it is pretty much obvious. Okay, so as you increase the word count, then of course the number of characters will increase. So there is a perfect positive correlation here. It's kind of it seems a 45-degree relation. That's mean as you increase word count at the same ratio, review length will increase. Alright, so this is about the pair plot. Now let's go ahead and see a swarm plot, how we can do a categorical plot. A swarm plot, I'm going to do it with sns.cat plot. And in the cat plot, I'm going to pass x is equal to division name. So there we have division name. And in the y, I'm going to pass their polarity. And then finally, the data, I'm going to pass here df. With this, we get here a swarm plot. In the swarm plot, it says that intimates. Alright, so intimate division has mostly the positive polarity, but this general division name has some negative polarity. It happens because it's pretty much clear with these three plots that there is most of the reviews are in general division. And that we have already seen in our previous lessons. So the most of the reviews are in general division name. All right, now let's go ahead and see it with the box plot, how we can do it with the box plot. Let's go ahead and copy it and paste it here, and then I'm gonna pass here a kind parameter, and that kind parameter is gonna be box. And then similarly, it says that the median value of polarity for all these division, it's around 0.25. That's mean the most of the reviews are positive reviews, and they are recommending those products from that e-commerce websites, or you can say the stores. Alright, so this is how you can plot with the division name. Now let's go ahead and plot it with the department. Alright, so there I'm going to use here a department. Alright, so there is a department name and y is a polarity. So with this we can see trend have a least number of reviews, and it seems the dresses and bottom department and this top. So these three departments have most number of reviews. And if you copy it and again paste it here, since this is the department, I'm going to change it department, and then I'm going to pass here kind is equal to box plot. It should work, I think. Let me see why this error is coming there. So it says that could not interpret. Yes, I think the department. Yes. All right, so there we have, it says that again for a trend, for this trend, median review polarity is a little less as comparison to all other 5 departments. All right, that's mean the store need to pay attention on this trend trend department. All right, now let's go ahead and see how we can see the division name and their review lengths. So that we can do with sns.catplot, and there I'm going to pass their x is equal to division, sorry, that's the division name, and then finally we have y is equal to review underscore len, then we have their data is equal to df, and then finally we have kind is equal to box. All right, so with this what we get here, we get this division name and review length in the form of box plot. So the x-axis is division name and then the review length. So there we get that general division and general petite have almost the same review length, and the intimate division have a little smaller review length size. All right, and similarly we can also do it with the department name as well. So let's go ahead and copy and paste it here, and then I'm gonna pass here department name, and it's pretty much clear that there we have dresses and jackets and then trend. So these have review length larger as comparison to these tops and intimates. All right, so this is all about in this lesson. Thanks for watching. I'll see you in the next lesson where we will see the distribution of sentiment polarity with the recommended scores. All right, now let's go ahead and continue our lesson on bivariate analysis. And before we continue this lesson, we need to import now Plotly Express and Plotly Graph object. So I'm gonna do it with import. Then I'm gonna write here a Plotly, import Plotly.express as px, and then I also need to import here Plotly.graph object. There we need this graph objects as go, that's mean this is graph object. And then also, yes, I think these sorry, I think these two are okay, perfectly to go. So the first of all I'm gonna get here x1, that's the polarity when it is high, that's mean when the recommended index is 1. All right, so there df.lock, that's mean get all those the df, that's mean the data frame which have polarity is equal to the the recommended index is equal to the 1. So there I'm going to pass it here df. All right, so inside this df I'm going to pass that I have there recommended index that says that when is equal to 2. All right, I think let me pass it here as well. So there we have x1. So now what we need this recommended ID, and we also need their polarity. All right, so there I'm gonna pass here inside this, yes, so I'm gonna get first this recommended index. All right, so I'm gonna pass it here, in fact, then I'm gonna paste it here, and then I also need here polarity. All right, so there now you, sorry, I think I need to put it into a 2 square bracket there. Now you will get your x1. So in the x1 we have a recommended index there, and then we have their polarity. Now what we need to do is the similarly we are gonna get here x0, that's mean when this recommended index is 0. So I'm just gonna copy it and paste it here, and with the same formula we have got there x0. Now what I'm gonna do here, I'm gonna plot here our trace 1. So there we have trace 1 is equal to go, that's the graph object, dot histogram. So it will be plotted in the form of histogram. So there x is equal to, I'm gonna pass there x0, and then I'm gonna pass here a name for this one, for this plot actually, that will be used as a legend name. That's mean not recommended. All right, and then I'm gonna also use their opacity, so that once two graphs for x1 and x0 are on the top of each other, then the background graph should be visible a little. So the opacity I'm gonna use here 0.8. all right, so let's go ahead and run it. Once we run it, then I'm gonna also copy it and paste it for trace number 2. So that's the trace 2. In this trace 2, this is, I'm gonna say that recommended, sorry, and then there is x1. So we have got their trace 1 and trace 2. Now we are gonna prepare their data. So that's the data is equal to in the form of list, that's the trace 0, and then there we have trace 1. all right, so this is now inside the data. Then let's go ahead and get the layout. We can get the layout is equal to go dot layout. That's mean this is a graph object layout. There I'm gonna say that graph mode is equal to overlay. That's mean these x1 and x0 can be plotted to each other, I mean on the top of each other. Then we have their title. In the title I'm gonna say that distribution of sentiment polarity. all right, polarity of reviews based on the recommendation. all right, so there we have it. And once it is done, then I'm gonna say here a fig is equal to go dot figure. Then we have their data is equal to data. Then we have their layout is equal to layout. And once you have this, then finally we can say here fig dot show. all right, so there we are gonna use their fig dot show. all right, it says that trace 0 is not defined. Yes, I think that's the trace 2. Let's go ahead and convert it into the trace 0 and then the trace 1. all right, with this it says that the module object is not callable. I think it is here a little wrong there, so that should have been overlay. all right, and still it says that it is not correct. Let me see why it is not correct. I think it is wrong here, so that L should be in the capital. And once you do this, you will get something like this. Oh, this is not pretty much clear. So what we are going to do here, we are going to remove this recommended index from here, and then similarly we are going to remove it from here as well. all right, so there we have x1 and the x2. Let's go ahead and see it. So there I think it's a little wrong there. If I remove this fig dot show and if I do it with iplot, so there I have iplot and then fig. Let's go ahead and see it. Okay, still just give me some time to fix it. Well, so I got the error is coming actually from here. So this creates it as a data frame, but we do not need it as a data frame. Once we put here a double square bracket, then any series becomes as a data frame. That you can check it here. Let's say if you run it there, then if you check there the type of x1, then you will get it as a data frame. But this data frame we do not need it, but we need it in the form of series. So if you use there a single square bracket, then you will get that as a series. So this is the series which we are going to pass it here, and then you will get here a bar plot there, and we have set the opacity as 0.8. I'm gonna decrease it a little, and then I'm gonna set it 0.7. So with this 0.7 you will get here a pretty much good plot, and this plot says that this is the recommended product, I mean recommended reviews. The most of the reviews are the positive reviews for the recommended, and there is a not recommended products. So the not recommended products also have a positive review, but they say that okay, this is the good, and but they have negative polarity as well, and the positive polarity for the not recommended and for the recommended product, but they also have their negative polarity. All right, so this is all about in this lesson. Thanks for watching. I'll see you in the next lesson. All right, now let's go ahead and plot the distribution of ratings based on the recommendation. Earlier we have plotted it based on the polarity of reviews, and I have given this heading, and then now I'm gonna plot it with the based on the ratings. So what we need to do, we actually need to copy these codes so that we can save some times and we can process it a little faster. You need to select this cell and then hold on a shift key in your keyboard and then click on this cell. Then you will see there the cell has been highlighted. Then you need to press a C key in your keyboard, and then finally you need to press that here. Select this cell and press a V key in your keyboard. Then you will see there just below of the selected cell a whole code is pasted here. Since we are working for a rating, so that polarity only need to change it to rating, and this also we only need to change their rating, and apart from that we only need to change here a little distribution of sentiment. It is actually the distribution of ratings. All right, so you can say the distribution of reviews rating based on the recommendation. All right, so let's go ahead and run it. Then we are gonna run the cell, and then we see here for a positive reviews, that's mean for a recommendation, and then there is also not recommended product. So the most of the not recommended products have either 1 star, 2 star and the 3 star rating, but the recommended products have a 4 star and the 5 star rating. But there is also a very small subset of not recommended products which have a high rating but the not recommended, and I think we do not have any not recommended but a 5 star product. All right, perfect. Now let's go ahead and see it with the distribution with the joint plot actually. So I'm going to write here SNS dot joint plot, and then I'm gonna pass there x is equal to first rating, and then y is equal to, let's go ahead and see the rating and the review length. Okay, so there y actually we can plot the joint plot only between two continuous variables, although we can do also categorical variables, but that is not recommended. So there we have y is equal to, so review len. All right, so there we have data is equal to df, that's the data frame, and let's go ahead and run it. So once you run it, you will see there we have x is equal to the rating, and then yeah, actually this rating is also a categorical variable. I'm going to change it to the polarity. All right, then you will see here a kind of pretty much good joint plot. And this is in the form of the scatter plot. If you want to change this plot type, that's mean the kind of this plot, you can pass their kind is equal to the KDE. Now it will be converted into a kernel density estimation plot. There, just wait a second, then you will see this plot. This is a very beautiful plot, and there you see the polarity is the mostly high, but the most of the polarity and review length is concentrated somewhere here. Apart from this, let's go ahead and copy it and check the polarity with the age. All right, so similarly I'm gonna put here age. So we are gonna see x, that's the polarity, and then the y is gonna be age here. Just wait a second. Now it is pretty much clear that the polarity is somewhere here, which is around 0.25, and the age is somewhere here. So the people who have given a rating and the age of those people are mostly concentrated somewhere 35 here, it seems. All right, and the overall the polarity is somewhere concentrated around 0.25. All right, so this is all about in this lesson. Thanks for watching. I'll see you in the next lesson.